Last talk of the day, but certainly not least, we've got Seth Art. He's a senior security advocate at Datadog, previously created and leaded the cloud pen testing practice at Bishop Fox. The title of the workshop is Exploiting Common Vulnerabilities in AWS Environments. Please give Seth a warm welcome.
Thank you. Can everybody hear me in the back? Raise your hand if you can hear me in the back. All right. Thank you for attending the workshop. So, a lot of the workshops have been having trouble because the Wi-Fi has been a little questionable. So hopefully you can either use your own personal hotspot or join one of the DEF CON, the open or the secure DEF CON Wi-Fi. You will need that if you want to participate in the workshop. So in this workshop, at least an hour and a half will be you hacking, and Amber and Julian and I can walk around and help you as needed. So there's a very hands-on workshop, although you can just listen if you'd like. So welcome to the workshop, Exploiting Common Vulnerabilities in AWS Environments. My name is Seth Art. I'm a senior security advocate at Datadog. I joined Datadog about 3 months ago, and in this new role, I get to work on open source projects and security research and conference presentations and workshops like this. I'm really excited to be in this new role, but before this new role, I had been a penetration tester for 14 years. So I started on the application security side. I then got the itch to do network pen testing, internal pen testing, external pen testing, wireless, which was really fun, physical, which is terrifying, but really fun, physical security pen tests. But what I really found that I liked the most was internal penetration tests. Objective-based, assume breach style testing, where a company might ask you to come in, plug into the network, and then see if you can go from that no credential point, just plugging into the network, what's the worst that can happen? Can you get access to the most sensitive data in the organization in a time box? Sometimes it's not plugging in from the network. Sometimes you're starting from the perspective of a compromised user. So let's assume that somebody has been phished, their laptop has been compromised. Should every domain user be able to get to the most sensitive information in the network? Probably not, right? And so that's the style of testing that I really enjoyed. So about 5 years ago, when I came over to Bishop Fox, I tried to get as many internal penetration tests as I could. And I started to notice a pattern. More and more, about 3 or 4 years ago, more and more of the penetration tests that we were being asked to do didn't have any Active Directory at all. It was organizations that either everybody had a MacBook, they were using something like Okta or Google Workspace for their identities. And so that whole internal methodology playbook that I had, starting from a domain user, was out the window. Right? Some of the high-level concepts still apply, but we had to think of a new methodology to cover this cloud-native type organization. Another type of thing we were asked to do is, okay, let's say a Kubernetes pod gets compromised. We have an application running or service running in our Kubernetes cluster. I want you to start from that perspective and let us know, can you break out of the cluster? Can you get administrative access to the cloud environment that the cluster lives in? Things like that. So we ended up creating the cloud penetration testing practice at Bishop Fox with 4 separate methodologies. One for AWS, one for GCP, one for Azure, and then one for Kubernetes. And so that's what I want to talk about today. I want to share some of that methodology with you all, and you're going to get some hands-on hacking, trying to exploit the type of things that either get you into a cloud environment or to see what post-exploitation looks like in the cloud. So I'd like Julian and Amber to raise your hands. So that's Amber right there. This is Julian right here. If you have any issues with connectivity or any questions about the labs, raise your hand and Amber and Julian will head over to you. How's the volume? Everything good? Good. A little more. All right. Is this? I think if I hold it closer, it's louder. All right. So first, I'm going to introduce the lab environment. Then I'm going to talk about, in my opinion, where penetration testing fits in the overall, bigger picture of offensive security in the cloud. Then we're going to do 3 labs together. The first lab is going to be from the perspective of a compromised employee. So an employee has lost their credentials, they checked in their credentials to GitHub or put them on Pastebin or stored them in a Docker container somewhere, what would an attacker do with those type of credentials? Or this also includes what would an attacker do if they phished an employee and gained access to their laptop, gained access to their identity provider, right? If you have access to somebody's Google Workspace, then you can just log into AWS if they can log into AWS, things like that. The next set of scenarios is going to be compromised workload scenarios. So these are cases, when I say workload, what I mean is something with compute in the cloud. So something that you can get code execution on is a good way to think about it. So the most obvious would be an EC2 instance, but you could also have a Kubernetes pod, a compromised task in an ECS cluster. It could even be a Lambda function. Over the years, many people have come up to me and said, I just got code execution, and it turns out I'm in a Lambda function. What do I do from that perspective, right? And then the last set of scenarios will be focused on exploiting the type of cloud resources that are not compute. So you can think of something like an S3 bucket was misconfigured, or an SNS topic, or an SQS queue. It's misconfigured, and a lot of people have this question, what do I do, right? Another one would be an ECR, a container repository, is misconfigured. What does post-exploitation look like in that scenario? So that's kind of the stuff we'll talk about in Lab 3. So today we're going to be using, if you've all created your account in the Datadog Learning Center. So this was created and used by Datadog to teach people about Datadog products, but we're not going to be using any Datadog products in the workshop today. All of that stuff's been stripped out. But what's amazing about this platform is it's going to give each and every one of you who create an account access to your own ephemeral AWS account that's going to be nuked at the end of the workshop. So don't worry about anything you do in there. It's just going to be recycled at the end of the workshop. And this AWS account has become pre-configured with Cloud Foxable in it. So Cloud Foxable is an open source tool that I wrote while at Bishop Fox that you can, in normal situation, deploy into your own playground or sandbox AWS account. But today, you don't have to do that because we have created an AWS account for each and every one of you who signed in. And what Cloud Foxable is, it's an intentionally vulnerable cloud CTF. So it has deployed 18 challenges worth of vulnerable resources into the cloud. The Learning Management Center is also going to give you a virtual machine that you can use. This virtual machine has been pre-configured with the AWS CLI. All the profiles that you'll need, or most of them, have become pre-configured. It has the CloudFox binary on it. It has PMapper. So you should have a lot of these tools just ready for the workshop. Okay, so now's a good opportunity. We'll take just a minute or two. If you haven't been able to enroll and create your account yet, now would be a good time. And so what you want to do is you want to start the course. And this is completely optional. If you want to track your progress and submit your flags to cloudfoxable.bishopfox.com, you can. That way, if you want to keep on playing later, you can do so. But that's just completely optional. All right. Is anybody having trouble accessing the learning environment? Raise your hand, and Amber or Julian can help. Keep your hand raised. Amber, we have one here. Oh, okay. I'll just take. Oh. All right, I'm just going to take a minute and walk around as well. Hopefully, you can all be successful in creating an account. What? Oh yeah. So this you aren't really going to be successful accessing this on your phone. I mean, it's technically possible, but it's not going to be easy. There's a lot of commands that you're going to be entering. So in that case, we can just kind of, I'll talk about it at a high level.
So I was able to run the command and everything.
Oh, perfect.
Yeah, but this Cloud Foxable, this is this is all free. Right?
You don't have to do that. It's free.
It's free.
It's free,
Okay.
but you don't have to use it.
It was like in the challenge itself, it had like a cost of like 10 cents per month. That's just part of the CTF, right?
Yeah, that's going to be, you don't have to pay any of that because this is like an account for you.
Okay.
Yeah.
I just want to make sure.
Yeah.
So it's all free.
Yeah, and you don't even have to register for Cloud Foxable, only if you want to. That's just for submitting the flags.
The flags here, or I can do the flags through there?
Do them all through there. Yeah.
Okay.
Yeah.
Thank you.
Yeah. Yeah, so one quick note, while you can submit your flags to cloudfoxable.bishopfox.com, we won't be using that for the instructions. You know, I've kind of modified the Cloud Foxable challenges to work in this learning environment for all of you. So I would say use the learning environment instructions. All right, so you're going to have another 10 minutes of me talking, and if you want to troubleshoot, you know, just raise your hand if you need Julian or Amber to come over to you. And I'm going to just talk a little bit about offensive security in the cloud, and hopefully in 10 minutes, we'll all have an opportunity to do some of these challenges together. Julian? All right, so I'd like to frame where I think penetration testing fits in the maturity model of cloud security or offensive cloud security. So just like in traditional penetration testing, I would say don't run too fast. Crawl, walk, run. So in a cloud environment, you still will have people installing software manually on things like EC2 instances, and they will forget that they installed that thing, and it will become vulnerable to an exploit. And so that's why you still want to do traditional vulnerability scanning whenever you can. However, you also have this concept of cloud security posture management. So there are a lot of open source tools that do this. There are a lot of commercial tools that do this. What they're all essentially doing is measuring the way you've configured your account against a baseline, a benchmark. The most popular one is the CIS benchmark. And so this is really great at finding things that are public, right? You might have however, it doesn't tell you anything about context, right? It might say of the 100 S3 buckets that you have, these 10 are public. 9 of them might be public on purpose, right? Maybe they're hosting, you know, web content. But the 10th one might be like, whoa, that one should definitely not be public, right? And so you still have to, you know, analyze these results. But this is the kind of thing that's really nice to be running nightly, basically, right? Every single day, continuously. You want to check to make sure that you've configured everything properly. Once you've gotten all that low-hanging fruit, then you want to start thinking about this objective-based penetration testing. And so the way this works is that you generally have a start point and an end point. I'm going to start from this perspective, and I want to try to achieve a particular goal. And when you're in the walk phase, this is when I would recommend building detection capabilities. So that usually involves tools, right? And logging, and building your response capabilities. That usually involves people and processes. Because in my opinion, there is no red teaming and purple teaming unless you have a blue team, right? The purpose of red teaming and blue teaming, again, in my opinion, is that it's testing the efficacy of these tools, these people, these processes. And so you need to have that set up, and you need to make sure that they're working. You can have all of the tools in the world, and they can alert and log everything, but if somebody accidentally, you know, missed an alert, then the process is broken and it's not going to work well. So that's what red team and purple teaming is all about. Okay, hopefully you can see this. You don't have to read everything. What I did here is I picked a random reference architecture diagram off of AWS's website. This, to me, is what it feels like on day one of a penetration test. Everything is unfamiliar. There might be AWS services that I've never heard of. There might be technologies in use that I've never heard of, right? And so you're kind of trying to grok what's going on in this image, and you're trying to build with your partner, either you're an internal team or your client, if you're a consultant, you're trying to say, what are the starting points and what are the trophy targets? So in this hypothetical example, so before we get to penetration testing, where can CSPM type stuff help us? Maybe the first thing I see here is there's an AMI that's a custom AMI, and we want to make sure that your custom AMIs are not public. There's actually a talk tomorrow at DEF CON talking about all the secrets and things people put inside their AMIs. CSPM might also really help you find, oh, hey, this elastic load balancer over here isn't logging, right? You want an automated tool to be able to look at all of that. Okay, so now that we have the CSPM side under our belt, let's talk about a hypothetical start point and end point. So we're going to say that this browser that provides access to virtual desktops is compromised. That's the start point. And we're going to say that we have an S3 bucket with our AI models that's super sensitive, and we have an RDS database with client data that's super sensitive. Okay, so now we've defined our start point and our end point. What's interesting here is that, if you notice, none of the arrows in the reference architecture diagram point to the AI models or the client database, right? The normal flow works all around it, but we have this sensitive stuff, and we want to make sure that somebody who compromises this browser can't inadvertently or unintendedly get into the sensitive stuff. So we're going to pretend that this gentleman is our attacker who's compromised this browser. We are going to then assume that that person has access to the virtual desktops. So we have a Linux one up top, we have in the bottom, a Windows one up top. And so now we're going to put on our penetration tester hats on, our hats on for the first time, and we're going to think, okay, what does it look like in the cloud? The first big difference is that we have to think about, does this EC2 instance have an IAM role attached to it? If it does, then that means that we have the permissions that are assigned to that IAM role. And there's something like 17,000 IAM permissions. So what does that mean as a penetration tester or as an attacker? It means that post-exploitation could be so different depending on what permissions you have. So what I'm going to be thinking is, okay, maybe I notice that I have permissions to access a bunch of EFS file shares. So I put my pen tester hat on. If I have access to look at those file shares, I'm going to rifle through those, look to see if I can find any secrets, sensitive information. Maybe I get lucky, and this is not too hypothetical, this happens all the time. I'll find just a file with credentials just sitting there in plain text. Right? Now I've gotten access to the RDS database and accomplished one of the objectives. Okay, so let's redo the scenario. Let's say we still have an IAM role, but this time the IAM role only gives us the ability to describe EC2 instances. Well, that's still helpful, right? Without that, we'd have to do blind port scanning, and a default VPC is a /16. That would take a very long time and be a very bad day. But if we have the ability to describe other EC2 instances on the environment, then we could scan the 10, 20, 200, 500 EC2 instances that are actually live, and maybe we find another app that's vulnerable to something like SSRF. That means we've gone from this first EC2 instance with maybe one permission, now we have access to a second role, and now this second role might have access to S3 star, so we can download all the objects from all the S3 buckets, and that's another example that we would exploit commonly on a cloud pen test. So hopefully that helps you set the stage, helps you start thinking like we do on a cloud penetration test. And now we're going to start the first hands-on lab. So for the first lab, you are performing a white box cloud penetration test. You're all going to be starting from the CTF starting user, and that is attached to the Cloud Foxable profile. This user has security audit policy for white box analysis, meaning I'm giving you white box access. You can describe and list all the things in the account. In my opinion, this is the only way, the only effective way to do cloud penetration testing. Otherwise, you're just wasting time enumerating things, right? If you're an internal team, time is money, right? If you're an external, if you're a consultancy, time is money. Why black box enumerate things if you're a trusted party when you don't have to? Now, if you're red teaming and you're trying to test the detection controls, then that's when you might want to give them black box scenarios, in my opinion. Okay, so you also have a few extra permissions, and these are specifically designed to help you capture the first couple of flags. So let's find these first 3 flags. So the first one I'm going to do with you. So for anybody who has access, we're going to do It's a Secret together. And then after that, I'm going to let you all do It's Another Secret and root on your own. And we're going to do 10 minutes together and have 15 minutes for you to just hack on your own. So again, raise your hand if you have any questions about access.
How long are the labs going to be available?
the labs are going to go away after the workshop.
So right after.
Yeah.
Sorry, I kept saying 24 hours.
Yeah. Nope. All right, so I'm going to walk you through the first one just to help you get familiar with what CloudFox is, what the environment looks like. So the first thing we're going to do, you can either copy or you can click this and it'll run. So we're going to test to make sure that our profile is working, and in this case it is. And I encourage you, even if you're doing these on your own, to use the solution, right? We only have a certain amount of time, so feel free to go through and read. I put a lot of methodology, our own methodology into the solutions, because there's obviously many ways to get to the same goal. All right, so the first thing we're going to do is just a quick hack to make sure that the IDE side of things is pointing to the right direction so that we can see our CloudFox output. And now we're going to run CloudFox's all checks command. So CloudFox AWS, the profile name, all checks. And so with this isn't really all the checks. There are a few checks that just take way too much time to include in all checks. But this is helping you get a lay of the land. We created CloudFox to help you gain situational awareness in unfamiliar cloud environments. So one of the most complicating things about AWS is that the resources are in different regions, for example, right? So you might look and see what are all the Lambda functions in this account, but you're only looking at one region at a time in the console. As a penetration tester, we want to be able to kind of quickly see where are all the Lambda functions across all regions, where are all the file systems, where are all the API gateways, where are all the databases. How often do we get caught?
Yeah, by an RBA.
What's an RBA? Okay, yeah, the question is how often do we get caught when we use a tool like this on a cloud penetration test? And to me, this is one of the big differentiators between that penetration testing and red teaming. So we work with our clients and say, we're going to be noisy. It is actually a great opportunity to measure your tools, to like alert your blue team and say, hey, these guys are not going to be stealthy, but you still want to make sure that you see what they're doing. And absolutely, these are noisy tools, so these will get caught, or should get caught. It's a great opportunity for that. Great question. All right, so the reason I set this up is because what you can do is head over to the IDE and look at all the output files through the browser. CloudFox creates 3 types of output for you by default: table, JSON, and CSV. I generally use the table files, and what it's doing is it's showing us things like, here, let me make it a little smaller. Okay, so for instance, right, the access keys command. I want to enumerate all of the access key IDs that I can. This is not sensitive, but what am I going to do with this as a penetration tester? I'm going to search for each one of these in GitHub, each one of these in Confluence and SharePoint, because I might find the secret part that corresponds with this key, and now I have access to another identity. So that's kind of like, to help you think. Here's another thing that CloudFox does, is it'll tell you the buckets, right? It'll enumerate all the buckets, but check out this loot directory. There's also, it gives you the commands to download all of the data in any of the buckets. But very intentionally, it does not do this on purpose. Some buckets have millions, billions of files in them, and you do not want to download all of that data, right? So as a penetration tester, you want to be judicious. So what the design principle for CloudFox is to give you the commands, but you have to use your experience to determine when it's the right bucket. So the first command in this gives you the ability to just list the files in the bucket. And then if the files look interesting, you could start downloading individual files that look interesting. You could download a whole bucket if it looks like it's appropriate, things like that. Okay, so now let's get back to the challenge. Okay, so the next thing we're going to do when this finishes, or actually I'm just going to kill this here, is in your lab, you have this thing called, a script called AWS console login. And so this is really cool. I'm going to run this, and it's going to create a sign-in URL. And so we can just log into the console as the lab user. And so you see here we're the AWS account. And so let's start to do this first challenge in the console. So we are starting from the perspective of the CTF starting user. So let's see what permissions that user has access to. So this CTF starting user has permissions in the form of permissions policies. Each policy has a set of permissions. And I think we're getting hit by DEF CON Wi-Fi. There we go. Okay, and we have a policy called It's a Secret policy. And if any of you have not seen what this policy looks like, you have an action that tells you kind of the verbs that you have access to. The effect is either allow or deny, and the resource. So this could be star, which means you could get all SSM parameters, but in this case, the resource is saying, no, we only have this permission, this action, on this resource. So the CTF user has the ability to download just this secret. So if we had access to do that in the console, we could do something like this. We're going to go to the Systems Manager. We're going to go to the Parameter Store. We're going to go to It's a Secret. And we're going to click this. But as you notice, we're not logged in as CTF starting user. We're logged into the lab AWS account role. It's a different role. This role doesn't have permissions. So now we're ready to go back into our workshop and access the secret through the CTF starting user. So CloudFox has a command that'll first enumerate the secrets for you. We see here's the secret that we're talking about. It's in US West 2. By the way, all of the resources are in US West 2 for this lab. And as I mentioned, CloudFox writes loot files, so we're going to cat the loot file. And this, again, CloudFox is teaching us the commands that we need to do the next thing. It doesn't automatically do it for you. And what we see here is there is this whole command that is the command needed to get that secret. So this isn't much hacking, this is just using the permissions that we have to get the secret flag. Because as a penetration tester, you're often jumping between different identities that you have access to, right? You start as one identity, then maybe eventually you compromise another, Each one of those are often in profiles. So the way this works is, here actually, we're gonna export profile equals cloudfoxable. And then now this command is going to work, and we have together captured the first flag. All right, so with that, I'm going to give you all 15 more minutes to try to capture the next flag. It's similar, except there's one more hop that you need to do. You need to go from one identity to another identity, and then you'll be able to capture the flag, right? On a penetration test, that's often the name of the game. As soon as you get access to new credentials, a new identity, that's a new set of permissions that you have access to. It might be fewer permissions that you previously had access to, it might be more, and it's kind of just following that path until you get to the objective. So please raise your hand if you have questions, if you need help on any of the access, or have questions about the challenges.
I can't do the questions.
Oh, and nothing happening there?
Yeah, I can't use the terminal.
Maybe try just refreshing.
And please keep your hand raised.
Huh?
I tried many times.
Yeah.
That works.
Let's see.
Use difficult Wi-Fi.
Okay, yeah. Let's see if it loads this time. Okay. Oh, you're in yeah, go back to that one, yeah. Oh, weird. Maybe try making it bigger and smaller. You know what? You can. I mean, you can go to the IDE. And oh, that doesn't work either.
Yeah.
Do you want to try in another browser or incognito mode, maybe? Try that, and I'll come back. You can log in again, and then yeah.
Hi. So two questions. First, I don't see the output in the.
Oh, did you do that command? Go up to the top. This one. Do run. Or click to terminal.
Okay.
And then this will reset. Okay. Now open the IDE. Uh-oh. Okay.
Okay.
Yeah.
So now it's way better.
Yeah.
Awesome. Thank
Cool.
you.
Yep.
So
Yeah.
we supposed to be like working. Basically, we're supposed to be impersonating the staging user, not
Right. Not that. Yeah. You can use this one for read-only access, but this is the one you want to start from. So it's the profile Cloud Foxable.
Gotcha. And so in log into the IDs, there's this one. Yes. As him.
Oh, you can't log in as Cloud Foxable to the console. So you'll just use the CTF starting user on the CLI.
Okay.
So-
You wanted to browse the file dump on the ED tab, but I don't think that's possible.
No,
is it?
Oh no, you can. Yeah, there's here. Can you show?
Comment for it.
Yeah, if anybody else has that, this one. It's at the top of challenge one.
Yeah. So yeah, you have to move the files around.
Yeah, that will restart the browser and point the default location to Cloud Foxable.
So what's this like now?
So that just allows you to log in as this role. So you can use that to hunt around, but what I want you to do is use the AWS CLI and CloudFox to get the actual commands,
Oh, gotcha.
or get the flags. Any questions? What?
All good?
So far good, yeah?
And they have internet.
Yeah, I think because everybody's leaving because the end of the day, maybe? Yeah. Thanks, yeah. Yeah. Any better luck? Oh, okay. Cross your fingers. That's so weird. Oh, no. Nothing works? I don't know. The only other thing, maybe try to create a new account. And I've never seen that.
What is that?
Just nothing's loading.
What browser are you using?
He was using Chrome.
Okay, the Chrome.
Are you logged
I
into
will
a
try it.
VPN? VPN is going to cause
Oh, I'll be right back. Oh, did you have any questions for me? You're good?
No.
Because
Yeah.
questions.
Yeah.
So as a pen tester, typically what permissions apart from security audit policy you would ask for your client or the team to run?
Yeah, great question. Okay, actually, I should talk that to everybody. Basically, what we ask is for two sets of permissions. Give us one user or role that has the security audit, but then also give us another one that has the objective-based permissions. So if you're going to simulate a developer, right, give us the role, or just let us assume like the developer role and start from that. Yeah.
So it depends from.
It depends based on the scenario, who you're trying to simulate. You know, if you want to make sure that your developers can't write to prod, that's a good place to start. Maybe you have like an ops team, or maybe, or maybe you're starting from a workload. So in that case, you can just give us access to the workload, and then whatever IAM policy would normally go on a workload like that, you'd add that.
The second question
Yeah.
is the CloudFox tool that you have here. Is it so? You know Scout Suite, right?
Yeah.
It does the operation and
Yeah.
stuff. So is it like noisy like Scout Suite, or this is a different?
Yeah, so it's noisy, but its purpose is different. Scout Suite is kind of, it's one of those tools like CSPM. It's measuring against the baseline, and it's supposed to give you findings. I purposely made CloudFox. It doesn't give you findings. It just gives you threads that might lead to findings. Things to search for. It gives you like IP addresses to scan. What happens is just a quick way to, like, if you get access to a new role, you can just quickly see what permissions that role has without expanding all of those policies. So it's like a helper tool.
Okay. So that role only needs like a security audit policy.
The CloudFox? Yeah, exactly. It's built to work with mostly security audit permissions.
And it's open source.
Open source. Yeah. Yeah. So one great question that I just had is, when we're doing a cloud penetration test, what permissions do we ask for? And so the answer is usually what we do is we say, give us 2 principles. One principle with this white box security audit type access, and then the other principle to simulate the starting point. So if it's a user, a developer, give us access to a role that you would normally give to that type of user. Or in the case of a compromised application or workload, give us the access to the workload, but then attach an IAM policy that would traditionally or normally be applied to a workload like that. And that's, so the one is your auditing type role for white box testing, and your other one is your objective-based access. And sometimes we start penetration tests with no IAM permissions, right? Kind of like that plugging into the network, and that's the case too.
So I was having this issue, so we restarted per the help file.
Okay, yeah.
And I keep getting, as soon as I run this,
Yeah.
I keep getting this.
Oh, and then that's a sign-in link. You click that, and it'll open up a tab.
That is a link.
It logs you in.
Oh, okay.
Yeah, it's really cool. So yeah, just log out first, and then if you click that link again. Okay, so now click that link again. And then it should open up. Yeah. And so now you're logged in. This isn't the Cloud Foxable profile, it's a different one, but it kind of has that security audit type
Okay,
position.
now I should be able to get the other steps going.
Yeah, this is just, you don't, yeah. Yeah. Are you doing 1 or 2?
It's a secret.
It's a secret. Okay, that's the one we did together. If you want, you can skip that one and do the second one.
Okay.
They're similar,
Okay.
but.
I'm glad I did, because this is where I was getting stuck. earlier,
Okay.
So thank
Okay.
you.
Yeah. So what I'm going to do, since there's a lot of people that don't have laptops, I'm not going to talk about what I'm doing. So if you're doing this on your own, go for it. But I'm just going to kind of silently work through the second challenge, just to kind of, so you can have something to look at. Yeah, if anybody's having a hard time hearing in the back, there's a bunch of seats in the front, so I encourage you to kind of move on up. talk about some of the things that we tried to learn during these challenges. All right, so let's do a quick review of IAM principles. So IAM principles consist of IAM users and IAM roles. Users can have long-term access, long-term security credentials, and roles have temporary security credentials. So for users, that's either username and password, or that is API keys. For a while, the best practice was users were used for human users, roles were used for service accounts. But over the years, we've all learned that users will absolutely save their credentials in places that they're not supposed to save them. So the general recommendation, the general best practice these days is to not use IAM users at all, as a last resort. Because we have this concept of federated identity. So now you can have federated identity providers like Okta, like Google Workspace, like Azure Active Directory, authenticate the user and verify their identity, and then you can have roles that are only allowed to be assumed by particular Okta groups or Azure Active Directory groups and things like that. So you can have a role called developer, and then all of the developers can access that role. And then you never have to worry about long-term access keys ever again. So what do they look like? This is a user. A user has permissions, and the permissions are one or more policies. And then you have roles that also have permissions, one or more policies that make up the permissions. But the difference is that roles have this trust policy, this trust relationship. And this is what that looks like. So this is a role trust policy saying that the CTF starting user can assume this role. This is like a run as in Windows, for example. And so what did we do in our first 3 challenges? In the first one, we started with CTF starting user. It simply had permission to get parameter for the flag. It's a secret. Now the second one that some of you worked on yourself, this time the user had to assume another role first. This is a path that we use a lot on cloud penetration tests because it's really complex. People make mistakes with role trust policies all the time. And so as CTF starting user, we assumed ERTS. ERTS had the ability to get it's a secret. And so here's a fun thing to think about, right? When you say who has the ability to access it's a secret, if you're not thinking about transitive trust, if you're not thinking about privilege escalation, you might say, oh, ERTS has the ability to get this secret, right? But if you're thinking like an attacker, you have to, your threat model has to include CTF starting user has the ability to get to ERTS who can get to the secret, so both of them have access to the secret. And this is a real fun one. This is a role assumption chain. So what I wanted to show you in this challenge is that there are a lot of different ways to mess up or to give access from one principal to a role. And so in the first one, we have the scenario where Kent has permission, SDS assume role star, and Beard has this concept of trusting :root. So what a lot of people think is that when you trust :root, you're trusting the root user, the first user you use to create the AWS account. That is not the case. What this :root notation means is that this role can be assumed by any principal in this account, provided that principal has the forward SDS assume role permission. So if you ever have a principal that has assume role star, all you need to do is look at all the roles, and any of them that trust :root, you have access to. So the SDS assume role star is a very dangerous permission because of that. So now we know Beard can access Lasso, but this is confusing because Beard doesn't have any permissions whatsoever. So how is this possible? Because if Lasso explicitly names the ARN for Beard, Beard doesn't need permission. It's explicitly granted. This is one of the few cases where you can have one-way trust. The role trust relationship allows the assumption by Beard without any permissions. Now, luckily this doesn't work cross-account. So if Beard was in another AWS account, it would have to have the SDS assume role permission. But intra-account, Even if you don't think you have access to assume lasso, it can't hurt to try to assume all the roles that you can enumerate. All right, so with Lab 2, we're going to talk about the compromised workload scenarios. So we're going to say that a workload has been compromised, the workload lives in a cloud environment, and we want to measure what is the impact of a compromised workload. So when I train junior penetration testers, I like to talk about these 3 pillars when you have access to a workload. You have network access to the VPC, most likely. Sometimes you have access to a Lambda that doesn't have access to the VPC, but if it's a Kubernetes pod, if it's an EC2 instance, you do. So can you exploit anything else in the VPC? Traditional network scanning, right? Can you find an SRF? Can you find an RCE in another application? You might have access to an IAM role. We covered this already, right? Any permissions that workload has access to, you have access to. Use those permissions. Try to enumerate them. You can enumerate them using black box methods. You can enumerate them using white box if you have that level of access. And then lastly, you have access to that host, right? Are there any environment variables on that host that have API keys or secrets? Are there any files that have intellectual property or secrets? Are there any running processes that are interesting? Is there any service listening on local hosts that maybe you can only access because you compromised the host? So that's kind of your high-level playbook if you've compromised a workload. Okay, so now we're going to click Next and get into Lab 2, where we're going to work on the Bastion challenge and the variable challenge. And so since there's a lot of people here, what I'm going to do is I did make a video of me exploiting this challenge. So I'm just going to play the video and talk through it. Or actually, no, maybe I'll just do the challenge and talk through it. So if you have access to it, feel free to do it on your own. But I'm going to kind of walk through this one for everybody. And there's still RCs at the front, so if you have a hard time hearing or you want to see the screen better, look for a seat up front. So first what I'm just going to do is I'm going to use EC2 to describe instances, and we're going to list all the other instances, or all the instances on the VPC. And now I'm going to show you basically why we created a tool like CloudFox to kind of just give you this information in a much more digestible way. So here you see that there's 2 instances. One is Wyatt, one is Bastion. And it's going to give us a loot file here with all of the SSM commands. So SSM is this really cool feature. So SSM is an IAM permission that allows you to connect to an EC2 instance, provided it has a few prerequisites. It has to be a modern version of Amazon Linux 2 or Ubuntu. It has to basically have the SSM client installed. It also has to have a specific policy installed as well. So it's a really great mechanism for connecting without having to worry about giving SSH keys that can be lost from a defender point of view. But from an attacker, this means now you can potentially just get an IAM permission that allows you to connect to EC2 instances, which in a lot of ways is sometimes easier than finding an SSH key. So we're going to use this second terminal here to connect to the SSL. Oh, I forgot to. So the first thing you want to do if you have access to an instance is check the instance metadata service and see if you have access to the instance metadata service. So that's what we're going to do right here. And this means we curl the metadata service 169.254, 169.254. And then the next thing we're going to do is if it has an IAM role attached to it, we will be able to. So what we did was we modified that to include metadata, IAM, security credentials, and the role name is Reina. So now all we have to do is basically hit the up arrow, add the name, and now we have access to the credentials. But here's the cool thing. You can use these credentials and take them off the compromised EC2 instance, use them on your laptop, use them on your attacker box, and that's absolutely fine. But you can also live off the land, right? So we can do which and a lot of times, hey, the AWS CLI is already installed here, so we don't have to steal those credentials. We can just do an AWS STS get caller identity. And if we're lucky, we'll get yeah. So this is using the instance metadata service under the hood to access the identity. And this is, if you're talking about red teaming at this point, it's a double-edged sword, right? On one hand, it's better to live off the land, but now if there's agents on here, they can detect what you're doing, right? So in that way, it might be better to use the creds off. On the other hand, there are ways to detect if you use the creds off the box. So if you are a mature detection team, you want to have detections that'll say, why is there an IAM role assigned to an EC2 instance being used completely outside of our VPC, right? Okay, so now here we got access to an EC2 instance with an IAM role. What permissions does it have? If we have that white box access, we can go to our Cloud Foxable account, we can look for permissions. We already have seen that pattern, but we can also use a tool like CloudFox or a tool like Enumerate IAM, or there's a bunch of different tools that'll basically just throw the kitchen sink, right? Try to list all the lambdas, try to list all the CloudFormation, try to list all the EC2s, try to list all the secrets. And the way it works is, if for CloudFox, we didn't design it to work in this way, but if it's just checking everything, whatever you have access to is what's going to show up. So that's what we're going to do right here. We're going to download CloudFox, the binary, and then we're going to run CloudFox's inventory command. And this is doing exactly that. It's checking ECR, EKS, ELB, Glue, Grafana, IAM, Lambda, and anything that comes out of this means that we have permission at least to list or describe, right? Here's the double-edged sword though. Just be mindful. You might have access to a role in a black box scenario. That role might have access to get a particular file out of an S3 bucket, but if you don't have the list buckets, right, or list all my buckets permission, you won't know in a black box scenario that you have that permission. The way these work is first they list all the buckets, and then if that's successful, then it tries to do the next step for each bucket. So just be mindful of that. So here we do see that we can list 3 S3 buckets, so that's great. Let's just confirm it using the straight up AWS CLI on our compromised workload. And here I'm just copy and pasting. I'm getting the name of the bucket, the Bastion bucket here. And now we're going to list all the files in this bucket. And look at that. Here's the flag. And so we're going to use AWS S3 copy. We just downloaded the flag. And here's the flag for the Bastion challenge. So this is very straightforward, right? On penetration tests, we often see overly permissive workloads. There are a lot of EC2 instances, a lot of Lambda functions that have a lot of permissions. So definitely this is something you want to look for. And as a defender, you really want to be using the principle of least privilege, right? The best way to do that is by using infrastructure as code. When you provision the instance, when you're provisioning the bucket or the SNS topic or whatever, you kind of use your variables so that you're only giving that resource access to that, or that workload access to the resources it needs. And that's the way to thwart these type of attacks. All right, so with the variable challenge, so this is another one. This is an interesting one. In penetration testing, often you find pieces of information through different ways, right? You have access to SharePoint or you have access to Confluence and you find credentials, but maybe you can't use those credentials, right? But then somewhere later along the line, you have access to a new system, and then that thing has access to the service. Finally, you put those two pieces together, you use the credentials, you use your new access, and now you can, get to the database. And so that's what we're going to do here. So I'm going to show you, and in doing this, what we're going to do is we're going to play with the tool PMapper, which is by far my favorite tool at mapping privilege escalation paths and transitive trust. All right, so in terminal 1, so what we're going to do now is we're going to do a Lambda list function. And what's interesting about this is, look at this. The Lambda has environment variables, and if we have the permission to list functions, we can see all the environment variables, and people often put all types of crazy stuff in Lambda environment variables. And this is wild, right? Because this is at the cloud metadata service. So we might not even have access to run this Lambda function. We might not have access to update the code for this Lambda function. But just by listing it, we have, right? And we just have security audit permission. So you just gave all your developers maybe read-only or security audit in prod. Well, if people are putting secrets that are read-write in the environment variables, then now your developers with that read-only access have write access to some things. And so one of my favorite CloudFox, oh, actually here's, one of my favorite CloudFox commands is this environment variables command, which will enumerate, I think I say, AppRunner, ECS, Lambda, Lightsail containers, and SageMaker. So far, the ones that I have found that use this pattern of environment variables at the metadata layer. And you can see, let's see, I might have to make this a little smaller. But you can see we have a bunch of Lambdas with a bunch of different credentials in them. So this is another challenge. Here's a Lambda with an HTTP username and password. And then this is a nice representation of the RDS username, password, the database name, and the host. But so to save some time, if I did nmap this RDS hostname from this terminal, from the virtual machine, I don't have access to it, right? But remember, we have access to this Bastion host over here, and this Bastion host does have access to it. So really, the rest of this challenge is essentially just using that access. Oh yeah, let me show you PMapper. So now we know that just having the permission Lambda list functions gives you access to this. So oftentimes in a penetration test, and as a defender, you want to ask the question, who has access to this permission, right? And so PMapper to the rescue. So PMapper uses, so this first command is going to create a graph. It's going to look at all the IAM policies. It's also going to look at all of the resource policies, right? Kind of like that role trust. You can have a resource policy applied to a bucket or a Lambda function that says, hey, I'm a Lambda function. I'm going to say that these three people, these principals have access to me. It's kind of a different model. And it combines those and it builds a graph and it allows you to say, okay, these two roles have access to this permission. These 8 users have access to this permission. And it goes a step further and it might give you attack chains. So it'll say, this user can privest to this user who does have access to list the functions. And so that's what we're going to see in a minute. And so there's two ways to use PMapper. You can look for just the privest paths, but in this lab, I've designed it intentionally so that nobody has a direct path to admin. So we're going to use the other mechanism, this who can. I don't know if you can see this. It says who can do, and then you put in the action, with, and then you put in the resource. And then you can do conditions if you want. Okay, so now that the graph has been created, so PMapper query, who can do Lambda list functions with star? And so this is that kind of transitive trust, right? So we see this user, CTF starting user is authorized to call it. That's why the CloudFox command worked. But check out this. Christian Pulisic over here can call Lambda list functions because he can access Tab Ramos through privilege escalation. So Christian Pulisic can create a stack in CloudFormation that then can, and has the permission then to pass the role Tab Ramos to that stack. So then, in theory, Christian Pulisic could create a stack, and the only purpose of the stack is to create another role that, so that, oh no, that's right. The stack can then list the function and get the environment variables. Okay, so now it's time to finally get the flag. We're going to copy. We're going to use the CloudFox's database command to just quickly get the name of that host. And we're going to go over to terminal 2 here. And now we're going to install Nmap and confirm that we have access to that host on 3306, which is the MySQL port. So on a pen test, this is kind of very much created because of a cool finding I found in a penetration test. This was a Kubernetes environment. I had access to the Kubernetes dashboard, and I could actually see all the environment variables attached to the pods, and I found the credentials, but I didn't have network access from my initial starting point. But I did have access to connect to the pod, so I then connected to the pod, and then from there was able to access the RDS database. And so the next thing we're going to do is we're going to install MySQL, the tool, and we're going to connect to the database. Oh, I need to get that password now. We're going to use this CloudFox database. And we've just gotten the flag from the credit card table. So that is our 2 challenges for compromised workloads. So now I'm going to switch over to the slides again. Okay, so let's recap. So in the first challenge, we simply used the role Reina to access the flag. And in the second one, we had to first use the Lambda list functions to get the credentials, but we didn't have access to the database there, so we then had to use the Bastion host, which gave us access to the VPC, and then we were able to access the database. All right, so in the last lab, we're going to talk about, this is a fun one, a compromised cloud resource. So we're going to deal with SNS for these next two labs. So what you need to know is that if you're not familiar, SNS topics and SQSQs are message brokers. They essentially receive messages from a producer, and then they deliver messages to subscribers. And often when you're doing cloud configuration review, your tool might find that, hey, you have a bunch of SNS topics that are, anybody in the world could publish to them, or anybody in the world could subscribe to them. And as an offensive security person, you want to answer the question, like, what does that mean, right? Is that bad or no? I don't know. And so the first thing to note is, it depends. If you have a topic that is not being used, right? Somebody created a topic, anybody could subscribe to it, anybody could publish to it, but no sensitive data is being sent to it by your systems. Nobody's consuming the data from it. I mean, it's a misconfiguration, but there's no impact, right? But if that topic is actually being used, that's information disclosure, if somebody can subscribe to it, and that's what we're going to see. And there's potential to do much worse if somebody could publish messages to it. So the next challenge, it's not fully what I saw on a penetration test, but on a penetration test what I saw was the topic that I had the ability to subscribe and publish to was accepting Python pickles, and something was consuming those pickles that had compute. So you could just do a deserialization attack that way. So this challenge is a little simpler than that, but it's the same idea, right? I think a lot of your eyes kind of went like this as soon as I said it was consuming pickles, right? Because a lot of times you can get code execution through these type of misconfigurations. So not a lot of times, but occasionally. Any questions on anything I've covered so far? All right, so now it's time to click next in to go to lab 3. There we go. All right, so there's two CloudFox commands that'll help you do this. Again, you can do all of this through the UI. You can look at you can do all this through CSPM tools, but we're going to run the CloudFox resource trust command. So this is, I think, one of the areas that a tool like CloudFox excels in. It's allowing you to look for the same pattern across multiple resource types. So this one's looking at S3 buckets, Lambda functions, anything that has a resource policy. So I'm going to make this really small just for a second so I can explain it. So I know this is really hard to see, but we're saying, so this is the resource, and first I'm telling you if it's public or not, and even if it's not public, is it interesting? And the only reason that these are not public is because I don't want your own lab environments to get popped, so I've put an IP address restriction, but think about it as if the IP restriction didn't exist, right? Anybody can publish or subscribe to this first topic, and same thing for this one, except here's an interesting condition. On the executioner one, only the principal account. So basically, any principal in this account can publish this topic. So this is a pattern that is usually there's good intentions, but it's often, opens up privilege escalation. We've even seen things where the resource policy says, this action's allowed by anybody in my organization, right? So that's, if you apply something like that in prod, then that means that anybody with access to dev can do the thing that you just put the condition on. So be careful with those conditions that are kind of at the account level or the org level. So, okay, so now there's also the SNS topic, or the SNS. And as you can imagine, the reason I'm calling this one out is because this one gives you the commands to subscribe or publish to the topic, which is just like a helper, essentially. And so I'm going to show you what exploitation of a topic that we can subscribe to looks like. So the first thing we're going to do is we're going to use the terminal 2, and we're going to set up a netcat listener. The cool thing about these labs here is that they all can listen on public ports, so that's going to be helpful. And now these commands that I'm highlighting right here, these are the commands that CloudFox generated for us. So we're going to export the CloudFox level profile. And when you have something that is accessible, like an SNS topic that allows anybody to subscribe to it, what does that mean? That means any principal from any AWS account can do that. So here they're all in the same account, but I can use my personal account and subscribe to the same topic. And so here's the command that's going to subscribe. And what I did was I basically just curled the IP address of this lab VM. And if we go over here, this is the message that we just got on netcat. It's a subscription message. And so if we click this, we have now just subscribed to the topic as an attacker, right? Our netcat listener has subscribed to the topic. And what we need to do is we need to restart that listener. And to make the challenge work, I have a process that's kind of recreating the challenge recreating the message every minute. So within a minute, we should see a message come across this topic. Something outside of our control is producing messages to this topic. Oh, this happens occasionally. Let's subscribe one more time. And here we go. Sensitive information is being sent to this topic that anybody in the world can access. So the way SNS works is you're going to have as many subscribers as you want, right? So anybody who subscribes to this message can just get a copy of anything that's sent to it, or subscribes to this topic can get a copy of the messages. SQS is a little different. You're actually kind of pulling messages off the queue. So you want to be careful in doing an attack like this, where you might actually pull real data off of the queue that might not get processed. So this isn't necessarily something that you want to do in production. It's something you might want to test, in a lab environment, but it is possible. It's just there's risks there. Another note is what we've done is we've listened a netcat clear text, right? If you're doing a real penetration test, your listener should be TLS, and you also want to unsubscribe at the end, right? You don't want to just leave your subscription. As a penetration tester, you don't want to leave your stuff laying around. So be polite, unsubscribe after. But here we can see first name John, last name Smith, and the social security number somewhere is our flag. The reason I hid this here is because as a penetration tester, sometimes you see stuff and you might miss the important thing, right? So sometimes you do have to look a little closely to see that, oh wow, there is a SSN here or something. Okay, so the last challenge we're going to do is we're going to do that code execution challenge. If you think that's cool and you want to do, there is another challenge so you can do this challenge on your own in Cloud Foxable after, but also there's another challenge that does take in that deserialization of pickles into account in Cloud Foxable, but we're just going to do a simpler version. So. You have a question? Yeah.
Can you list subscribers for topic?
Yes. Yeah, we're gonna actually do that in the next challenge. Okay. Yeah, you can list it. And it's kind of funny seeing it in yeah, 4, yeah. So you can list subscribers on your topics. That was the question. Can you see who subscribed to your topic? And you can.
Is that possible with CloudFox, or would you have to?
Not possible with CloudFox. It's just I just don't have that in there. But there's an AWS command to list. We're going to actually see it. It's in the solution for the next challenge. All right, so for this one, I'm just going to speed along a little bit, right? So we have another topic called the executioner, and this is the one that allowed anybody in this account to subscribe to it or publish to it. So even if you have like an auditor, or even if you have a third party that you're trusting, any principal in this account can subscribe or publish to this topic. So we're going to do a Netcat listener on a different port this time. And we're going to use the Vinicius Jr. profile here. And here, let's do one of these one at a time. In Terminal 1. So we're going to go through the same process of subscribing. So here we got the subscriber URL. Hopefully we only have to do this once. Start listening again. All right, here we go. So now look at this message here. This is the actual message that was sent to the topic. Echo hello world. So I see that and I'm like, hey, wait a minute. That's an OS command. Is there OS code injector, OS command injection, right? What is consuming this? So to answer your question, let's first use our white box access. And we're going to do the AWS SNS list subscriptions by topic. And we're going to put in this topic name, executioner. And so this is what I thought was funny, right? It's always funny to see this. So we are subscribed to the topic, our IP address on 1337, but also this is the aha or the oh crap moment. There's a Lambda function subscribed to this topic. So if we're lucky, that Lambda function is actually executing that echo command. It's very possible it's not, right? But if we're lucky, it is. So now we're gonna, kill that listener. Then we're gonna start a new listener on 8888. So the first thing we want to do is, what do we want to do? What's our payload? Reverse shell? Let's try it. So I'm using the bash, interactive bash shell through the dev TCP trick. So I've just saved you all a lot of time and trouble, because what you might want to try to do is use Netcat first for your callback, right? Or other tools. But these Lambda functions are running very stripped down, right, operating systems essentially, right? Like the tools on the Lambda function, the Lambda runtime are, first of all, it depends. Is it Python? Is it Node? Is it Java, right? But so you can always kind of rely on the old bash dev TCP trick. And so we did that, and let's see what we get on our listener. Wait a minute, we got a connection received, but it closed before we even had access to it. Now if you have control of the Lambda function, you can create a Lambda function that has like a 5-minute, 15-minute timeout. But if you don't have that, by default, it's just going to time out right away, right? It ran the command, it timed out. So does anybody have an idea how we could exploit this Lambda function?
Add a command with a delay.
Add a command with a delay, that's a good one. Try to do like a wait, right, after. That's one. Not you, Austin. Anybody else? How can we exploit this Lambda function without a reverse shell? Without an interactive reverse shell?
invoke it. Invoke the Lambda function.
What?
Invoke it.
Oh, invoke it? We invoke the Lambda function, so that's a different type of attack. If we had the permission to invoke it, we could absolutely do that. But this one, we have kind of that we're just have code within the runtime. Here's a hint. Lambda functions don't use the IMDS. How do they get access to their roles? Does anybody know? Austin?
Environment variables.
Environment variables. So what can we do? Forget about the interactive bash shell. Why don't we just modify that payload to just pipe the output of the env command across our network port? So let's restart the listener. And so what you see here is instead of the bash I, right, we're just running env on the Lambda function and then sending the output of that to our listener. And here we go. All the Lambda environment variables, including the AWS session token, the AWS secret key, and the AWS key ID. So now we can essentially, I mean, this it feels like magic, right? You can configure a profile on your laptop that is acting as the permissions assigned to the Lambda function. It feels like you shouldn't be able to do that, but you can. So this part I have to do manually. So let's go ahead and help me find, okay, this is the ID. Now let's find the key. And the token. Cross your fingers. All right, so now we are acting as the ream role, which is the one that was assigned to the Lambda function. And so to drive home, I know I skipped a lot because we're doing this interactively, but as a penetration tester, this is the process. I think I can't underscore this enough. Every time you get access to a new IAM role, a new IAM principal, the first question is, well, what permissions does this one have access to? So let's for the last time. And again, you can absolutely do this through the AWS CLI. You can do this through the UI. We're just going to use CloudFox for this. And our white box access, which is really nice. And we see that it has access to this final parameter. And so I'm going to skip some of the, we've already done this before. We're just going to print out the command. Oh, running the secrets. Okay, so here's the command. So again, this whole thing where I'm exporting the profile, this is just a CloudFox specific thing so that I can constantly switch between profiles. So here, it's going to export. Right, I created the profile ream. And now let's get that last flag. All right, so hopefully that was enjoyable. Let's wrap up the presentation. There we go. Okay, so what do we see in the first challenge? Any principal from any AWS account could subscribe to the first topic. Now you might be asking yourself, how would somebody from another account even find the ARN for that topic? You need the ARN to subscribe to it. And that's a really good question. Like, it's not super easy, but it could be in JavaScript, it could be in source code, it could be in an internal knowledge base, right? Maybe you just have it, it's like in a knowledge base somewhere, and so somebody was like, hey, I found an SNS topic, let me see if I can subscribe to it, right? So it's not impossible, but it's not easily discoverable by anybody on the internet, per se. And in the next one, we first subscribed to the topic, then we published something to it. We learned that the Lambda function was also subscribed to it. It accessed it, executed our code, we accessed Ream, and then accessed the flag because we exploited Ream's permissions. So, a reminder for anybody that used the lab environment, they're all going to be nuked at the end of this workshop. You can spin up Cloud Foxable on your own Playground account. Do not deploy Cloud Foxable to a production account. It's got lots of vulnerable stuff in it. But you absolutely can play with Cloud Foxable after this workshop. And it's not a red team if you have no blue team. It's just a penetration test. That's just my personal opinion on the matter. And mostly, if you had to sum up how is cloud penetration testing different, IAM is king. Always be mindful of what IAM permissions you have access to, and always remember that it's not just the last principal that has access to the thing, it's anybody who can get to the last principal also has access to the resource. So thank you all very much for sitting with me for 2 hours. And feel free to hit up this short URL. It's a Google form. I would love feedback. Was it too slow, too fast? And also the slides are there as well if you want to grab them.